Today, well, first of all, we're going to start with our mission statement. I'm Chantel. I'm with Career and Internship Services. It is our mission to, or it's our job to engage you in the career planning process through self-assessment, understanding of what is available in the world of work so you can set goals and market yourself. And I know I'm reading this. We'll help connect you with employers to help you embark on a successful career path, whatever you determine that to be. And that is what we are here to do. How we do that is through different services like mycatcareers.com. Hopefully you are all on mycatcareers.com. If not, I highly, highly suggest you pick up a card, or there's an instruction sheet over there, a little more detail about how to get registered and how to search for jobs on mycatcareers. All kinds of stuff on there, student employment if you need to work part-time while you're going to school, if you need summer jobs, if you need a job just for the weekend. We have people calling all the time that I need help moving firewood today. So if you need a temporary job or just some quick cash, get on there. There's also internships available. So as you're working towards your career path, you want to try out some jobs, maybe you need the internship credit with your program. Internships are also listed on there, and then of course full-time employment. This is available to you as an alumni after you graduate forever. So remember your login and password. The rest of your we also offer career coaching and advising, and these career coaches are wonderful. They'll help you figure out. They'll do some resume critiques with you, mock interviewing, so that you're ready for things like on-campus interviews. You'll have your resume ready when for career fair, when we have our career fairs. Like I said, alumni employment also, we have a lot of employers that are looking for experienced workers as well. So once you graduate, if you change jobs, if something happens in the economy, we've had a lot of alumni recently getting back online and calling to get their logins and passwords and learn how to use mycatcareers. We offer fairs, workshops, presentations all the time. There's also another brochure. Forgive me for having to get up and down like this. All kinds of workshops on this brochure on the back. Obviously, we're towards the end of the semester. There's only a few left this semester, but we'll have a whole new one here in just another month or so. And then we have a library full of resources for you in our office. So please swing by. We're right over there in 177. There for you, and all of our services are free to you as well. This is our career model. The career coaches will work with you on this. Usually, generally, during your freshman year, you'll start with the self-assessment, figure out what motivates you, what are your interests, work that into the world of work. How does that fit into that world of work? What's going to be a good path for you? And then set goals. Working from that, setting some goals on where do I go from here, try some internships, maybe study abroad, try some summer jobs, that kind of thing, and then working finally. So you usually go from your freshman, sophomore, junior, senior year, really hit the job searching hard at that point, doing some on-campus interviews, and they'll help you figure out how to negotiate an offer.
My name's Gabe, as mentioned. I'm head of product at Golden Helix. So to give you a background of where I come from, and then probably more interestingly what Golden Helix is. I actually did my undergraduate here at MSU in computer science. I came into the program knowing exactly what I wanted, or at least I thought I did. And John gave me the world there as I started tackling on more than I could chew, but it was an extremely engaging, fun program here at MSU, and really developed my passion for computing, but more importantly, sort of what computing can do in the real world. So I actually was lucky enough to land an internship at Golden Helix while I was doing my undergraduate degree. Really helped, one, pay for college, but two, really, and I encourage this for everybody, it's not just about learning the theory, it's not just about learning the sort of the practice from a exercise perspective. It's about really knowing why you're doing something. And so having a job or having any type of real-world application in which you're applying the things you're learning makes the learning process so much more applicable, engaging, exciting. And I know there's lots of opportunities inside the computer science department to do those types of things, and I definitely encourage that. So I was an intern for the full 4 years in which I was doing my undergraduate. Actually, I think I finished at 3.5. But after that, I actually got promoted to sort of a director level position at Golden Helix. We were a small company, we were just starting to add on a couple more people. And from there I actually took my leave and pursued a graduate degree in computer science from the University of Utah. So Salt Lake City's got a lot to offer there. There's also a lot of applied science, which is again one of the things I was really passionate about. They have a great program where they integrate a lot of their medical and other types of engineering work with their computer science program. I focused actually, I ended up focusing, I sort of went all over the place, but I ended up falling in love with language theory and focusing on that in my graduate research, and actually worked on sort of high-scale parallelization, which is essentially we were using commodity GPUs, those things that make your computer games look freaking awesome, are also really good at running a lot of calculations in parallel. In the case of my advisor, she was being funded by the Department of Energy to take a whole bunch of simulation code for, I don't even know what the code is for, it's probably nuclear physics or such, but take all that and be able to run it on more commodity hardware in a more automated fashion. So that was a lot of fun. So when I finished that, I had a couple different career options ahead of me. Interviewed at Google and got a great job offer there, but I did also get sort of teased back to come to work at Golden Helix at a higher position to really focus on the product strategy. And now I get to talk to you about Golden Helix, which is a great opportunity because I want you all to come work for me eventually. But what we're doing is essentially trying to enable genomic research to be advancing us towards more meaningful applications of genomics in clinical care. Right now it's mostly a research effort because genomics itself is still being figured out, but the technology is crazy fast in its innovation cycle. If you look at how those little graphs of like Moore's Law, I don't know if you guys have seen this, but you know, back in the 80s and like every 2 years, CPUs got a little bit faster and you buy your Pentium 133 and then your 266 the next year and all that kind of stuff. How many people like have any concept of what a Pentium chip is? All right, like this is before Core. So yeah, if you were building your own computer white boxes back in the day, the crazy thing is like that technology curve is like doubled when it comes to genomic sequencing. Like back in 2000, it cost $1 billion to sequence a single human genome, and Bill Clinton shook the hand of the team that did it, and it was a lot of fun. But nowadays, you can get it done for about $1,000 of raw costs. It costs more because actually you're producing so much data, it costs tens of thousands of dollars just to run that through machines. So the nice thing is, lots of data being produced, a good problem for computer science to figure out what the heck to do with it all. So that's kind of what I do in my day. Is I work with mostly academic researchers currently, and I'm looking forward in the next 2 to 3 years to seeing a lot of that technology transition into actual clinical practice, where if you go in with an undiagnosed genetic disorder, they're going to be able to get to the bottom of it in a matter of weeks or days, or right there in the lab, as opposed to currently, I mean, unfortunately, it still takes years to get to some of these diagnoses. So, so that's what I've been doing since about 2010 or so. So I've been running the product side of Golden Helix. Yeah, any more background than that, or is that a good start?
That's a great start.
Yeah. Cool. I'm Jordan Schatz. My background is a little bit different. I started out with a problem. So my family, I have a family of entrepreneurs. My father had his business, my grandfather had his business. I was expected to have one in my teens. So I was having landscaping business when I was 15 or so. And we were starting to get to a lot of clients, but there was no software to run the business. There was nothing specialized to what I needed. So I started running software because I had a business and it had a problem, I was going to fix it. When I was 17, I competed in a science fair in Billings. Didn't place too well, but started learning cryptography and number theory. And then after that, I never got the degree, but I studied at a variety of places. Some in Salt Lake, a lot of stuff online. MIT is putting a lot of stuff online. Berkeley has been for a long time. So I studied where I could, and I studied the masters. So went back to the art of computer programming, the structure and interpretation of computer programs, some of the great texts, and started there, and learned from the history on up. Most people that work with me have no idea I don't have a degree, because usually I'm the guy that sounds like he's been around for forever anyway. So in Salt Lake, I worked for several startups. Usually had a lead engineering position, someone leading the team. A few different startups, some made some money, some didn't. That's the way startups go. Then I've moved back here. I've been contracting and running my own business for a couple of years now, I don't know, 4 or 5. Sometimes employing people, sometimes not. What I do, what my company has done, is help startups, usually when they're beginning to scale, they have a product, they're starting to get some customers, and the stuff they built in a couple months is breaking. Or they haven't yet built something, they have a problem, so they come to us and we get it done. We've worked in all kinds of languages, everything, languages you've probably never heard of, TAS, object-oriented, COBOL, if anyone's old enough. Then modern stuff as well, PHP, Python. My favorite is Lisp, JavaScript. We've been working on a new framework, incorporating best practices for the different stars that we've worked with that will hopefully deliver web applications faster and faster to the client. I think that's pretty good. Then ask questions.
I do, just so you know, I have some prizes for people who are most involved in asking the most questions tonight. So let's take some questions from the audience. If you guys have any.
Fire away.
Yeah.
All right. So, how important would you say, like, getting a degree, or like to what extent that, like, would have helped you? I guess.
I haven't found a degree useful. I have found the education very useful, and I have not found many people without a degree that bother to get the education. Does that make sense?
Yeah.
So the people I've worked with never really cared about the degree. They cared whether I had something that I could demonstrate, and the people I've hired are the same. Master's degree student came to me, and he didn't have anything he could show he worked on. He had a project he'd done in school in a different area that he didn't seem to be able to communicate. Another high school student came to me with a website that had 30,000 users that he built himself. This high school student got the job. So proven track of programs you've written, projects that are either profitable or that are popular are at least as good as the degree. And it depends a lot on the employer as well.
Yeah, so yeah, I throw my hat in the same sort of tone. What I generally do on a programming interview is, one, there's a huge amount of just assessing the kind of culture fit and making sure you're someone that I would be excited to have on my team. In the case of my company, it's still actually very small, and it's a very aggressive space, fast moving, like I said, technologically, but also we're competing with other companies, open source tools, etc. And I simply expect or demand that people have a lot of sort of initiative and ability to solve problems very independently and work in a team environment where they can handle that sort of expectation of one. I mean, it's not that I expect a skill set that's perfected, but simply that you are able to go out and take initiative. And so what I usually look for, that's a hard thing to sort of assess in an interview, is similarly that you've gone out and you found something you were excited about and you did it. Like, so whether it is code, and usually expect it to be code, some project, some side gigs, some toy that you're building, whatever it is, I kind of expect that level of I don't know what the word is, go get it-ness or whatever, right? But second, sort of on the degree side, there is a level of expectation that with a degree comes a certain basic, let's say, baseline set of grammar and way of talking about things. So if you have a computer science degree, bachelor's of computer science, I can say, do you know if that algorithm you're trying is going to be, n squared, and maybe we really should be looking at figuring out a way to make that optimal? Can't we find a constant time solution, right? Now, if you didn't have a computer science degree, I wouldn't expect you to understand that. If you did, I'm just going to expect you to understand that. At the same time, if you're reading SICP and the art of computer programming, you can understand that as well, right? So,
If they have a degree or not, I expect you to know that.
Exactly. And similarly, I'm not going to just assume that what's on paper from any university is translatable into a direct skill set. And so what I generally do is, after a good interview, we set up essentially a programming contest, kind of like the one that John hosts at the university, where we give you a simple problem and we see how you solve it. And we really are looking for, one, can you do it in a reasonable amount of time? and two, kind of what your thought process is, and it's literally not that hard of a problem. It shouldn't be unaccomplishable within a couple hours or something. But it's amazing that people who even they can get to the point of having a strong academic credential. The phrase I use is they can't really code their way out of a wet paper bag. It's like that challenge can be a very clear distinction between people who've spent time coding, and it's not like it's an intellectually difficult thing. It's just a matter of practice, right? It's people who have spent time doing something, and again, if you were passionate enough to do it on the side, you're probably doing it enough. And people who sort of just do the minimal to get by academically. And I've seen PhD candidates similarly fall flat on their face in this type of situation. And so it doesn't reflect, a degree doesn't sort of give you a pass, let's put it that way. You're always going to have to show through your own enthusiasm and initiative what you're capable of and kind of what kind of person you are to work with.
Yeah, we don't do any coding tests. I find it's not a very good measure for what we want. What I want to see is a good GitHub account with a bunch of things you built, open source contributions, or the stuff you've actually built. Whether you can do it under pressure in an hour, doesn't much matter, just show me you have done it before.
And I'll just throw in a couple things too from the professor's standpoint. So when you think about computer science, two of the most famous people, Bill Gates and Steve Jobs, don't have college degrees. But this is really the exception, not the norm. I think I just follow up what Gabe and Jordan were saying, and I think in general, if you have a computer science computing degree, that is correlated with generally an ability to solve real problems in the real world. And so while you still have to know your stuff, I think for most people, and Jordan, you said that well, for most people, that's the best way to acquire those skills.
That baseline. Okay, there was, I think, a question in the second row here.
Oh, well, I was just I had a specific question for you about Golden Helix. When you're dealing with GPU computing, are you guys working with a specific API like OpenCL or CUDA?
Yeah, we use OpenCL at Golden Helix.
Okay.
Just because we do have, we're selling to a very broad range of consumers that have different hardware. We don't want to be stuck with just NVIDIA. There's potentially more optimization, and in my grad research, I was able to beat OpenCL with using CUDA directly because they fine-tuned their APIs and I could get a lot of performance out of it. But that's sort of a wash when it comes to the type of work we're trying to do. So it becomes application specific pretty quickly. So yeah, we use OpenCL, and in fact, we used it for a specific problem. And I wish there's more problems that needed that solution because it's so freaking fun to build that stuff. But that problem ended up being relatively confined. What you need is a problem where you have a small amount of data that takes a large number of fairly trivializable parallel processes to compute on, right? So you need small input, large compute. Genomics has turned into large data.
So that quickly. PCI bus or the PCI Express bus is limited there.
And so what we actually do for the big data chunking, we don't necessarily play in this field too much, but we have a little bit. Most people just throw that up on the cloud and do a whole lot of computers because it's a lot of I/O. You can throw all your terabytes of genomic data up on S3, you can stream it down to individual nodes, do a lot of work, put the results back in, and then sort of get the aggregate data out for sort of downstream analysis. At that point, you've sort of condensed your problem space from a terabyte of data to usually a couple hundred megabytes.
For either of you, something I've always heard as far as the job market goes is to get a good job, it's either all about the networking, the people that you know, or if you have a specific skill set that you can sell. How relevant is that in the computer science field? For, say, someone who just graduated and is looking to get out there?
Well, if you just graduated, I don't expect you to know a lot of people, right? But, like we both mentioned, we really like if you have a track record. And it doesn't have to be, to me, it's like doesn't have to be a GitHub account. I love GitHub and we use it all the time as well. But if you have just something you can show me and show me the code, show me what you've done, that demonstrates your skill more than than your words necessarily, but I also am not looking for someone who I put in the closet and expect code to come out the bottom of the door. They have to interact in my team, and they have to be someone I can trust and communicate with, and I can actually solve problems to, and have good verbal communication in that sense. So, that actually stereotype actually, I don't think really exists in the real world more than sort of in the Hollywoodized versions of what happened in Silicon Valley in the 80s. Because really, and this is something that you kind of learn more and more over time, what makes a successful career, or I guess one of the keys to a successful career is more than you would believe marketing yourself, right? And that is something you expect over time. You can take advantage of over time. But coming out of a school situation, yeah, I am going to look at what skills you have. I am going to look at whatever track record you have, if you can show anything you've done. But I'm also going to look at are you the type of person I want on my team?
Yeah.
How important are her behavioral interviews now?
Behavior interviews?
Behavioral. Can't talk.
What is a behavior interview?
Tell me a time when you worked on a project and you ran into, a problem. How'd you solve it?
Right. Well, I'm not gonna again. I don't do the sort of quizzes in interviews either. What's the Fibonacci sequence for blah 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 or whatever, or go on the whiteboard and do fuzzbaz or whatever. Right. Well, that's a fun one. But what I do definitely ask sort of the ethical questions because, again, because our company is small, every hire has to be someone we could trust with sort of the keys to the chest, in the sense that, we're not going to be micromanaging, we're not going to be making sure that you're doing your, you should be expressing all the sort of values that would allow me to trust that if I give you a job, you're going to go do it, you're going to put your best effort to it and not goof off or whatever. So yeah, I do ask the kind of ethical questions. I am looking for people that I would trust with the security codes to our server room or, the access codes to our source code and all that kind of stuff. And ultimately, teams, again, there's that interpersonal relationship. And, we do have wonky personalities, of course, and so we do have egos and all of that. If people can't learn to resolve conflict, it's not going to work. I mean, you simply can't get stuff done in a world where you're always right or whatever. So yeah, there's some of that you definitely have to look for, but it's within reason too. I mean, I also expect a little bit of ego. You should be proud of what you do or what your ideas are. So.
Sure. And to the prior question, you can find jobs even if you don't have a network, even if you don't have a project. The magic solution is persistence.
Yeah.
You keep sending out the resumes, keep doing things, and there's plenty of opportunity. There's many people hiring right now. Do the things that she mentioned. Have someone else look at your resume. Maybe make 2 or 3 resumes, and then A/B test how many responses you get. It works. One of the best engineers I found. We had made a posting just to Craigslist, and he sent back a response, and then I replied to him. And then he replied to me again saying, that first response wasn't actually me. That was my automated program that searches all Craigslist, uses Bayesian filtering, depending on which ones will match me, automatically makes tailored response. So that was, that was not problem. He was coming in for an interview. So just persistence, and then, you're programmers. Go find a way to hack it and make it work.
Yeah, and following up also on that question, and are you a computer science major?
Yes, I am.
Yeah, we're
third year.
Third year, okay. So another thing, and this probably sounds like kooky type of networking, but you can network with your professors who are oftentimes aware of a lot of opportunities in the community. So I can tell you in each of the last 3 years, Bozeman alone has far more demand for people with computing skills than graduates that we're producing. And we maintain a jobs forum. Oftentimes, we know people like Gabe, like Jordan, who might be out there. Right now, for example, Web Filings, they're looking for 10 plus people at 60,000 plus a year. They do want the bachelor's degree. But there's all sorts of opportunity. And so if you're not aware where to go, talk to some people who might be in tune with what's going on even here locally. And in terms of, following up on something Gabe mentioned, so it's true that, like if you look at your career and with a computer science degree, you might be envisioning okay, I'm going to be at a desk with a computer. I would say your technical skills are about half of your ability to succeed in a career. And about half of your success is ultimately going to be in other types of areas. So I would say here are some areas that I find in talking to recruiters that are very, very valuable for students to have. So they involve not only good communication and interpersonal skills. One of the other ones is, are you able to connect computing with other fields? So I think we know we're living in a world where computing is pervasive. And so one of the real opportunities in computing, and I think we can see this with Golden Helix, is we need to figure out how to solve problems in genomics as computer scientists. Well, that means you have to communicate with people out of your discipline. So crossing interdisciplinary boundaries, very good skill to have. Being able to work with people from other cultures and other nationalities, this is also very valuable. We live in a global workforce. Most companies, when they reach a certain size, you might have offices in foreign locations. You might have colleagues who come from a different culture. Being confident traveling, being confident working with these people, that's also really valuable. Leadership skills, if anything you can do to develop leadership skills as a college student, that will serve you well in whatever organization you get involved in. If you understand how business works at all, you will be able to better contribute to the organization that you work for. So one of the things I've found, I've been the department head for the last 5 years, it's all about figuring out the business of the department, and if I can align what the department is doing with what the president wants the university to be going, guess what, we get resources. And so understanding how what you're doing fits into the overall organization, very important. So if you're on a project that's very important to Gabe, guess what, you're noticed by Gabe. If you're on sort of a peripheral project, well, great that you're doing okay, but you're never noticed to the same level. So that whole entrepreneurship thing is another really, really good thing to go after. So just realize that the technical skills are half your career. The other half are super important.
And it really is a global workforce. The best engineer I ever hired lives in Serbia, and we work with companies internationally, nationally, every day. So the job market is all the way across the country and across the pond too.
You had a question right there. Go ahead.
Is there a specific attitude you look for when interviewing?
Attitude?
Personality.
Personality?
Persistence and teachability.
Yeah, persistence is huge. Yeah, and learnability. I mean, you'd be able to sort of overcome the roadblocks. And that's the thing is it's not about just can you solve a problem. It's if you've never seen something before, are you gonna get stuck? And how do you get unstuck? That's actually something I asked. Okay, so I give you a problem, you've never seen it before. It looks like this. What do you do when you get stuck, right? And it's not, it's not that I expect you to work in a vacuum. I expect some of the answers to be, well, I think this person might be a good person to ask for help, and I know how to look up stuff on Google, right? And I know MIT OpenCourseWare has a course on that. Maybe I would go look at their index to see if there's a known solution or whatever. So it's about sort of that. I guess that is a personality trait, but that persistence and ability to self-teach and self-learn, and to me, that's part of that thing I was asking about, or looking for in terms of finding some hobby or project that someone's passionate about. It just shows that they're able to teach themselves something new independently, because it's not about just having a specific skill set coming out of college. In computer science, it's always an evolving world of technology that you always have to be learning. And if you don't have a passion for learning or continuing to keep up for that, essentially your skill set is going to, although there'll be a theoretical base that's sound and sticks forever, over time you won't be able to keep up.
Yeah. There's a famous programmer, Douglas Crockford, and he says about 90% of programming is staring down the abyss, which is when you think you have it right, you wrote it, it looks right, and it still doesn't work. And then if you spend longer than 2 hours on that, that's a problem. You need to either get help from someone else, talk to a superior or manager, try a different attack, leave it away and do something else. So both the persistence and then the ability to know when it's enough, when to give it to someone else and go to learn somewhere. I think all the way in the back has one.
Yeah. I came from a really small school in Hawaii, and I had never heard of computer science until I came here. And I'm a freshman, and I just feel it feels really sad that I never heard about it. And you say that there's a high demand here in Bozeman. Why do you think that women, or I don't know, maybe it seems like a male operated field, honestly, but,
It doesn't
So,
happen.
right, so I'll take a first pass at this. So first of all, just so you know, I mean, it's a worldwide phenomenon that the demand is like this and the supply is like that. It's manifested in Bozeman, but that's nothing unique to Bozeman. One of the great things about a computing degree is if you want to work in Berlin, Germany, Kyoto, Japan, they have the same sort of situation. So then the other part of the question is a very interesting one, and that is, why is this such a male-oriented field? And you know, like for context, in the early 1970s, so 40 years ago, biology was a male-dominated field, yet today it's a field that's very much in gender balance. We start off in our very first programming course, you know, like the first course for Majors 111, it's 20% women, it's 80% men. And I'm asking myself a lot of the time too, what in the world is going on here? Because here you have a career where you can do socially impactful things. You could, you know, help provide better medical care. You could help solve environmental problems. You can write apps for cell phones. Basically, whatever your interest is, software could probably be relevant. Like in Africa, people are writing apps so that people that are in remote villages can better get better prenatal care for babies. There's so much social relevance to how this can all play out. And so I speculate that there's a couple things going on. One is, and I think Gabe alluded to this, there's a you know, if you think about how does the popular media portray people that are in computing careers, oftentimes the portrayal, this is kind of my belief, it's a fairly negative one. It is a male, and it's oftentimes someone with little to no social skills who works alone, where code flows out of the closet. Right. That is the stereotype. And yet, that is a stereotype maybe from the late 80s and early 90s when there were a lot of people that, you know, like at that time were sort of code jockeys and doing things. It's a very different world today. And so I think my hope is that as more and more people realize about the opportunities that are there in computing, we're going to see basically it's not just women that are underrepresented. If you are not a white or Asian male, you are underrepresented in computing. That's the demographic that's currently dominant. And so because of that, companies, and I'll just use Google as an example, they have done studies of their groups, and guess what they found? Their most productive groups are their most gender diverse groups. And the reason is, and this should make perfect sense, if you're making a product that millions of people are going to use, if you only have guys designing it, it's not going to be as usable by everyone as if both women and guys together are designing. And so a lot of companies, you know, so where I'm going with this is, if you are a woman in computing, right now we are sort of at this, you know, kind of what I would call sort of a cusp where there is so much opportunity. You have even more opportunities than the men do because companies are all realizing that gender balanced teams are more productive, and then in turn it's a real opportunity to then help figure out what's going on in the K through 12 system as to why, you know, why are women coming into college not even considering computing as a possible career when it pays so well and has so much social opportunity. So that's my answer, and I'll turn things over to the other.
Can I say something, because I actually know the answer to that. So the studies have shown that girls are better than boys at math. So this is an engineering problem, not just computer science. But when they hit the junior high level, they become disinterested in the sciences. So there's a lot of work and effort out there to reach these middle school girls, mentor them in high school, mentor them in college, mentor them when they get the job so that they're successful. Because not only are you not bringing women in, they're leaving once they become senior engineers. So, and that's.
I think it's really, if you look at like math, as you said, it's actually fairly more gender diverse, gender neutral.
It's not that the computer science theory or any of that stuff is any more geared toward one gender or the other. It's just, I mean, if you look at the complexity of medical degrees and all these other things, women can do this stuff just as well as guys. So it's really, there's nothing to it other than sort of a social, I think it's just purely a social momentum. I have 7 people on my team, 3 of them are ladies. They all came from the math background. 2 of them have masters in statistics and mathematics, one of them has a bachelor's in mathematics. They all program too. And they all program because it was a necessity, and I use it a lot. But they could, and it's just simply that the numbers don't, I just don't have ladies walking through the door interviewing for computer science positions. So yeah, in my mind it's purely just a weird social momentum, and I really hope that whatever we can do to reach out to the junior high gals that are interested in engineering and mathematics and just keep that passion alive, because it's just a great field, and the more the merrier.
We definitely want more women in the field. There's a saying that there's more than one way to solve a problem, and computer science is only... So, anyway, having been in it for a while, the computers get faster. Languages change a little bit. Computer science stays pretty still, and only changes maybe every 10 years, every 15 years. That happens to be about when people start retiring. We don't have enough new ideas, enough different ways of solving the problem. Like you mentioned, we increase productivity when we have different ethnicities, different genders and stuff coming together, and we get better ideas. It also hasn't always been this way. The reason why we program, instead of each computer being unique, is probably Ada Lovelace, which if you go look it up, she was a mathematician. She wrote the first programming language. She started people learning to use language instead of programming them on the hardware.
And I named my dog after her.
And she's a really good teacher. Go, I think it was, I can't remember, 1920 or whatever. No, she was early, but not that early. Go look on YouTube. There's videos of her teaching. She's a good teacher, and it's cool. From my reading and from my own observation, a large portion of why there aren't more women in the field, like you said, by the time you guys get to college, there's already 80-20. So the problem happens earlier. From the studies I've read and from my observation, it actually happens very young, elementary school, and it happens because the teachers respond a little bit differently to the genders. The thing is that young girls and stuff start to communicate earlier. We say that they develop earlier, and then the things they're going to hear from their teacher are, "Oh, you're so smart. Oh, how well you did." And then the boys are going to, only time they're ever going to get praised is, "Oh, you kept at it. You worked really hard." And then later, by the time they get to high school, when the girls encounter a hard problem and it doesn't fall right away, then they think they're not as smart, because they've always been praised when they're on up through kindergarten and elementary school for being smart, for being intelligent, for being good at that. And then when 90% of hard problems, you're going to be staring into that abyss, and you want to have that built up, that it doesn't matter how smart you are. The smartest guys make mistakes, the smartest guys get stuck, the smartest gals get stuck. It's whether you'll keep at it. And we train the boys up to think that's the only way, and we train the girls up to think they have to be smart in order to leave.
A couple more questions. Wow.
Go ahead. I've kind of got a two-part question, actually. So what software development life cycles do you guys employ? And so that's the first question. The second one is, to what, effect do you see utilizing software development techniques to be useful in your respective
This is like software engineering type question?
Yeah.
Are you meaning like agile, waterfall?
That's right. Agile, like a Scrum based technique.
All right. Anyone know when the Agile Manifesto was signed?
Was signed?
I think it was 1985.
Okay.
Most companies haven't implemented it yet.
Yes.
That's because they haven't retired or died yet. It's broken. Agile is better than the way most people do it. Agile is broken, and we should have replaced it 10 years ago, but almost nobody knows that. Yes, it helps. Tons of projects fail all the time because they're not implemented right, they're not planned right. We can and should be doing better. We're not, and we probably won't until you guys get into the field and somebody somebody retires.
Yeah, so I have a lot of different thoughts on that. Last year I did a guest lecture at the software engineering course, so I could share my own project, where I guess it's really about the team management and software lifecycle management that I did at my own company, and I think some of the things I've learned. But ultimately, the first thing to keep in mind is it's the right tool for the job. A lot of the agile and extreme programming and a lot of that methodology, the people who built it in a consumable form and sort of created the product of the methodology, they're consultants, right? So their gigs are about get in, learn a problem, iterate very often because there's a lot of unknown unknowns,
iterate with the customer so that they are happy with what you get out of a consulting agreement, deliver a product, get out, right? And so that actually, for that, there's some definitely benefits to those types of methodologies. The other thing to keep in mind, though, is that if you are a startup, you're going to have a very different methodology, right? It's about getting to a minimal viable product immediately, learning from your customer base. Engagement with your customer is going to be so much more important than pretty much anything else you do, etc. If you are a mature company who's very risk adverse, you're going to have a different methodology, right? If you're a bank and you're implementing something that's going to be handling credit card processing, it's going to be about ISO this and compliance that, and can I make this the least painful thing possible? I'm scared, right? And if you're, and I actually get to experience a couple of different methodologies even within my own team, because I have a mature product and I have a new product and I have sort of a Web 2.0 product. So I get 3 different products to learn different techniques on. And on the mature product, we've gone to a very drumbeat release cycle where I have monthly releases. My QA manager actually decides what goes in that release. If something's not ready, it doesn't get pulled into that release. So I literally can't shove something out the door that I want until it's QA'd, because the most important thing for that mature product is that the scientists that are using it don't get scared by shoddy or unfinished stuff, and that there's a very consistent and I guess predictable release cycle. So we say every month, first Thursday of the month, we get a release. That's actually something we've come to over a long period of trial and error. It works really, really well for our case. And then we essentially just use best practices. We can use distributed version control, so developers can be working in their own branches, then the stable release branch. We can be using nightly builds. You've seen the Joel list of of things a software company should be using, otherwise you should be a little bit scared, right? Do they use version control? Right? You should definitely be using version control. You should be learning about these things even if you don't have the need for multiple people to work on a project. That's usually something you get to in a capstone course. Play with it before then, because it's extremely useful concepts to be familiar with. Do you have nightly builds? Do you know when something breaks and you have a continuous integration system? I don't think it's that every time a piece of code changes you have to have everything change, but we do have nightly builds and everything like that. And then on our new product, our methodology is actually about sort of getting the most innovation for the buck, right? I don't have a lot of customers. I don't have a lot of release schedules I got to keep to. I just need to build something that is going to be a good foundation for the future and meets or solves a really hard problem well. So there's a very different cycle there, and so I lean a lot on my senior engineers to put their all into sort of the innovation process. I give them a lot of leeway, and I do a lot of coaching, and I do a lot of back-end work, and I do a lot of trying to build the environment where they can plow forward and build crazy awesome code, so crazy awesome products. So.
Look at some of the blogs from GitHub and 37 Signals. They're doing a lot of the newer stuff.
Yeah, GitHub's crazy good on their release stuff. They release multiple times a day and all that.
Yeah. For most of my there are software as a service companies that come to us and we fix their software. Whenever possible, we tell them they're not done, they're not ready, don't leave us yet until the owner's wife can deploy the software. Okay, and safely. Okay, so it's not going to break nothing. But continuous deployment, tests, that kind of stuff. 95% of the companies aren't using what we know as best practices, and best practices are from 1985 when the manifesto was signed. Open source is where the most bang for your buck for the much development effort. Open source is the best development methodology we humans have found yet. Someone should be studying it. I don't know of anyone who is. So do it for your masters.
I had a couple different questions. One was going back to when you're looking at candidates hiring, how much you value kind of the skill sets, knowledge, experience versus the ability of, particularly problem-solving ability. And then I had a separate question specifically for you. You were talking about how you're using the cloud with nodes for distribution. Have you looked at all at or have you used, or are you thinking of using any of the available volunteer distributed computing that's it's been.
Oh, like sitting at home, but like from the modern version of that?
Yeah. I mean, there are different. Like there's one most common one, like the Boink client, I think, that allows companies to put up. And I know there are issues with that, but I'm just curious what you think of that.
Well, in our case, our data is probably a little too sensitive to be sending to a place that sounds sketchy. But again, marketing, right? Yeah. It's important. And people, customers want to feel very confident, and for some reason, EC2 and Amazon has gotten the pass for a lot of people. It's not that it's a perfect world, but it gets a lot of scrutiny. So, sort of by mass adoption, it's getting a lot of sort of okayness from people who would otherwise be wary to put their data out on other people's computers. What was the first question? Oh yeah, skill set versus problem solving. Yeah, my quick pitch is it's actually kind of hard to get a really good read on somebody in just an hour on how good of a problem solver they are. I could be fairly confident in my interviewing skills, but I wouldn't be that confident. I wouldn't be able to say, between two people, I could figure out who's the better problem solver in an hour. I could try, but I probably, so that's why, track record or, your GitHub account can be a huge benefit to you because, if you're a good problem solver, show us, what have you done? What problems have you solved, right? Competing in the local programming contest, great way to demonstrate problem solving skills. In fact, I met one of my recent hires at the programming contest last year, and he did quite well. So immediately, he had it up in my interview. I trusted that he was a good problem solver, and now I was looking for other things. So,
I don't like problem solving one is usually we give you a test, we give you some problem to solve and see how well you do it. It matters more which problems you're solving, maybe rather than how well you are. And I can't give you a worthwhile problem in an hour. And I'd rather if I didn't have to give you the problem, but you went and found out yourself. So I don't care much. I've not found it good for interviews. Just doesn't give good results. Then your skill set. It matters if you know more principles than a language. If you know Java, and we don't use Java, I don't care. You can hopefully learn another language in a few weeks. No big deal. You can't learn it as well as I'd like you to learn it, but you're starting to work at it. But do you know static and dynamic typing? Have you any idea what a macro is? Programmable code, dynamic code. Can you tell the difference between what the CLR is and what the JVM is? So some principles, and then just some background knowledge, so showing that you can learn things and you have.
Okay.
Man, we're going to have to keep going with this quickly.
Short answer, stay a while.
So when you're going to hire someone, how important is it to have an internship on a resume?
Good question.
Any track record, any work history is a huge help, right? If you come out cold from a computer science degree and you're looking for a job and you can't show me a lick of what you've done in the past 4 years, how am I supposed to know what you're capable of, right? I mean, how am I supposed to know anything about you? Like I said, I can't learn everything in an hour, although, even we could talk about all the favorite books, etc. But I mean, it really is so helpful to have a track record. So yeah, internships are extremely good because what that does is give me an ability to say, oh, okay, what did you do there, right? And I'm actually really looking for is, did you find something that you could really sink your teeth into, be proud of, how you went about solving the problems in your internship job. Your internship job, in fact, I hired my quality assurance manager and she was working at MSU doing filings of, she had an internship at the hospital doing filings of medical records, and she was so excited about how she solved this problem where their medical records were getting lost, and she figured out a way to sort of create a process in which everything got organized properly, and then the ones that were misplaced got replaced in the right place, and I was like, wow, that's awesome, right? And so that kind of information, even if it's not even in the field, it's so useful to have that sort of track record.
A track record is good. Try and make sure it's a good track record. In general, I'd say an internship would help. For my company specifically, if that internship, it's a little, maybe, I can't talk tonight. I don't want to see that you've done a free internship. I don't want you in the habit of spending your time for free. I want to see that somebody paid you for whatever you created.
Are there free internships these days?
Yeah. Yes.
You want to work for me for free, I guess.
I'm not interested in that. Shouldn't be on your resume. Okay. That's all.
Okay, one last question in the back.
Okay, so I know we kind of touched on this, but what, like right now as students, what would you specifically kind of recommend us to be doing besides, we talked about the coding contests and building a track record and stuff like that, but like specific things that you think would probably be beneficial, like I know Mr. Paxton has talked about like what was it called, like entrepreneurship and stuff like that. Like, is there anything you have to say towards that end?
Sure. I like entrepreneurship, and I don't care what problem you find some problem and solve it, or contribute to an open source project. But as far as academics, learn a variety of languages. Different languages have different ideas. Lisp for macros, dynamic programming, Erlang for distributed systems, JavaScript for its unique type system. Just throw in a variety, and then I'd say definitely learn Unix or Linux or something like that. Even if you later program on Windows, you need to know how a real operating system ought to work.
Yeah, those are solid suggestions. I would also say read code. Read lots and lots of code. Find something that you were interested in. Like if you were looking at your browser and like, oh, this is Firefox, this is how interesting, or even Chrome. Chrome is an extremely interesting code base to read. Go read the code base, it's open source. And you'll be surprised that you can actually, it will seem daunting, that's fine. You'll be surprised that there's actually a lot of very understandable, approachable components to that code. But reading code is something that pays off with dividends throughout your career. It's like learning to read books, when you get those first assignments of those wonky books, like the ones in the 8th grade English course, there's no point to them. But what it builds up is the ability to understand someone else's thought process, coming in completely blind. And that is so valuable, because ultimately, you don't work in a vacuum. You're going to be looking at other people's problems. You're going to have to come in from scratch, understand what they were doing, what they're, what they were trying to accomplish, and then why it's broken and all that kind of stuff. So reading code is huge. The other thing is reading code makes you much better of a coder. And similarly, if you can't read code in other languages, you can't, if it's just a single language, you're dead in the water. Some of the greatest, algorithmic code is still written in Fortran and still used, right? All the BLAST libraries are essentially still Fortran. It's not that you have to go read those, but I'm just as an example. There's going to be all types of opportunities to gain knowledge by just going out there and reading code. But definitely learn Unix. Get on that Linux command line prompt. Be familiar with your grep and your sed and your gawk and your, at least learn one command line editor. I don't leave Emacs most of my day, but if you can't open up something on a remote terminal, logged into a cloud node, and configure an Etsy file, you're essentially stuck, right? And I don't like people who get stuck.
Yeah. A very small percentage of your time will be spent writing new code. You'll be reading code, you'll be testing code, you'll be going through requirements, you'll be doing research, so learn the other skills. And then learn some computer history too. He mentioned Emacs, I use it as well. Emacs is older than Linux, it's older than most Unixes, it's older than probably everyone in this room, and there's been a lot of mistakes made, a lot of things learned. Go learn why they did it that way, and why it worked, and why they regret it, or why they really think that that's the way, why is the program, so many programs, companies disappear in 7 years. Why has Emacs stayed around for 46 or whatever?
Who knows who wrote the GNU public license? Yeah. Like
go do your homework.
So this is very true. History repeats itself, and if you don't understand kind of why this field has had its successes, you won't be able to take advantage of those looking forward. And it also helps you refine where you need to pay your attention to, because you'll see a lot of hype coming about. There'll be a new language, there'll be a new framework, etc. A little bit of history will be like, oh yeah, well that's essentially the same thing they've been doing back in the 90s with Racket or whatever. Right? It's like we're relearning Lisp macro programming all over again, C#. Woo! So.
And it's not just computer science. Computer science, bridges to other fields really easily. So there is the GNU license. If you don't know it, a lot of open source software is under it, and then so a lot of companies, a lot of people contribute, a lot of people have code, a lot of people have a stake. We need a new version. So they came up with a way where 30,000 people contributed online and discussed and came up with a new version without fighting. Iceland, historically, like in the 1200s, always came together to make the constitution each year with everyone from the entire continent. Well, they're learning they want to make a new constitution, and they want everyone to have their input. So they are looking at what the GNU license did, and I think within the next year they're going to have a crowdsourced constitution. So this is political science, this is psychology, this is more than just numbers and math. And it's cool to learn the history and find out what's been done and what hasn't.
It's a really cool history.
So who did write the license?
Richard Stallman.
Okay.
Who also wrote Emacs? What's that?
I said, do you have a pet name after him?
No, if I had more pets. That I get to name. My wife named the other pets.
Yeah. Okay. Thank you all for your participation, and thank you all for your questions. This is just a really quick graph from the Bureau of Labor Statistics about your degree, earnings, and your unemployment rate. So the higher your degree, less likely you are to be unemployed, and hopefully, except for those doctoral degrees, more money you're going to earn. I think it's because they all go back to teaching.
It's over 9 months.
Yeah. So we do a survey every year of our graduates, and our callers are in our office right now making these calls. After you graduate from MSU, you will get a call from Career Services asking you what you're doing, where you're working, how much you're making. Please accept those calls and answer the questions. It is really helpful to students like yourself to find out where they're going after they graduate and what's going on, and what's the potential for you. So in our last survey, we had here's our response rate. 78.4% of respondents are employed or in grad school full time. So that's our numbers are coming. And then, yeah, I won't get into that part. Average salary by year and degree, and this is just across the college, not finance specifically, but bachelor's, master's, and doctorate degree. Here's our in and out of state average salaries again across the college. Obviously, generally speaking, you're going to make more moving out of Montana. We all kind of know that, but there's a reason why we're all here, right? And then here, this is by college. Those engineers. Yeah. And then location of grads, employed grads by college as well. A lot of them are staying in state, so a lot of people are we're keeping a lot of you guys here in state, which is really good news for a land grant school like ourselves. Just some key points. We you hear this, I swear, every single workshop we do, there's some key points that you can draw out of every single one. Do an internship, give something a try. Communicate with your advisor, who you know, make some connections. A lot of times you'll hear that graduate's first job, or if they are unemployed later on down the line, they call back their advisor. What do you know that's going on in the industry? And they're good networkers for that. Attend some workshops. Thank you all for coming to this one. And meet with a career coach. And the career coach is really, as I was listening to everybody speak, they're going to help you figure out, like, what are your niches, where can you go, where your interests and talents are, and maybe that's something you can work into your degree and really set yourself apart when you're interviewing. And then, of course, use all of our services here at Career Services. They're all available to you. They're free. Take advantage of that.